Page 299, example number 5, part B. So this example here, you can see it's a nasty one. No, because it's really big numbers. And then it has coefficients, fractions, radical numbers. So I always just like to simplify my radicals first. It just makes my work a lot easier. So I'm going to take this root 240 and see if I can simplify this further. So root 240 can be divided by 16. And then I think 15 is left over, which gives me 4 root 15. So what I have here is 3 was already there. I just converted root 240 into 4 root 15. So that gives me 12 root 15. So that part is done. Now I'm going to see if I can simplify my denominator, which is root 108. What perfect square can I divide 108 with? 36, and then I'm left with a 3, which gives me 6 root 3. So that just gave me 6 root 3, 6 root 3. So this all of a sudden became a lot simpler, right? So I was able to simplify this as much as I could. Now, lucky for me, what happens is that 6 will be divided by the 12 and 6 will reduce each other, so that will become a 2, as well as 15 will get divided by the 3 and it will become 5. In case I was not able to get rid of the denominator here, it was not something that I could divide out, I would have rationalized it. I think that happens in the first example, so why don't we see that as well? So what I mean to say is, in the first example in A here, if I were to simplify this completely, this comes out and becomes 10 root 5. I'm so skipping a whole bunch of steps about simplifying it, but this ends up becoming 10 root 5, and this becomes 3 root 3. So at this step, just like we had that 12 root 6 and this happening, this is what it simplified to. So as you can see, nothing really divides out. But the most important thing is that my radical didn't divide out. That is a problem. We cannot leave a radical in the denominator. So what you have to do over here is you have to rationalize it by multiplying it by root 3, both numerator and denominator. Not by root 5. We don't care about the numerator. It's the denominator with the root 3 that is causing us a problem. Not this 3. It's this root 3. Because of this, I multiplied everything by root 3 here. So what would that happen? Now 10, there's nothing to multiply 10 with, so 10 stays as 10. Root 5 and root 3 become root 15. That's just our simple multiplication. There's nothing to multiply the 3 with, so that 3 stays at itself. But these two multiply to become root 9. So why did we do this? We did all of this because we wanted this to become just a 3. So when you rationalize the denominator, your rational number in the denominator will always become a whole number. And the top will still just stay as 10 root 15, which then just becomes 10 root 15 over 9. Nothing got reduced, but that's not what we were trying to do at this point. If it does reduce, great. But the most important part is we don't want the radical to be in the denominator. So you would check if something reduces. 10 and 9 can't reduce each other. 15 and 9 are not allowed to reduce each other because one is a radical number, one is a whole number. And 15 can't be simplified any further. So we looked at everything from every angle. So that means that's my final answer. Now, if you go into the next example, number 6, they want us to do that example by rationalizing by denominator and also by dividing by the numerator. So I'm going to do the second part first because that's something we already did in example number 3, where we gave the denominator to both the numerator and denominator. And again, this will only work because root 2 can divide them very nicely. Okay, so because this 2 can divide out both the numerator and both numerators evenly, that's the only time this method would work. So this was pretty good. So that ended up giving me 10 minus root 7, which is the final answer because these two cannot combine. Now what happens if they cannot reduce? So let's say instead of it being root 3, 2, it was root 3. Then you cannot use the second method. Then you have to use this method, which is rationalizing the denominator. So in that case, what you end up doing is, if you ever come across a situation where this number does not divide both of them, then you multiply both numerator and denominator by that denominator. So you rationalize the denominator. So that will always give you root 4. But what happens here is you have a binomial being multiplied by this number. So you're going to distribute that in. So that ends up giving you 2 root 100 minus root of 28. So that gives you then 2 times 10 minus, so I'm just going to take what root 28 will simplify to. That will be root 4 root 7, so that's 2 root 7. So 2 root 7, and then this gives you just 2. So that gives you 20 minus 2 root 7 all over 2. Now, if I want to divide this 2, I have to be able to reduce every term with it. So that becomes 10 minus 1 root 7. So that ends up being my answer. So definitely longer, but if you can't do this second method, you have to do this first method. So it's always good to check if you can simply just do the second method where the denominator will divide out each of the numerators. Then you're like, yay, let's do a little dance. But if it doesn't, then you do have to do the first method, which is a little longer, but it's doable. Okay, so hopefully you guys can do your homework from this lesson. And if you have any questions, we'll talk about it next time.